Right, let's see. Here. All right, let's go ahead and get going. I posted on Canvas, just so you're all aware, I won't be on campus tomorrow and Monday. So that doesn't really affect our class meetings, but if you're looking for me in office hours, I won't be around. So just be aware of that. Offer still stands if you want to take one of those practice exams that your teacher has posted and send it to me, like scan a PDF of it and email it to me. I will happily, I don't know if I'll exactly grade it, but I'll certainly provide feedback for it and let you know where you might need to work more on stuff. So if you do that and send it to me, I will certainly get it back to you relatively quickly. Yeah, all right. So I'm just looking at some problems here that I made up that are similar-ish to your homework, but not exactly the same. Let's look at this first limit here. When you calculate the limit as h goes to 0 of 3 times 5 plus h squared minus 3 times 5 squared all over h. If we multiply this out, let's see what we get. So I get the limit as h goes to 0 of 3 times. When you set up something like 5 plus h squared, you're going to see this a lot, so you might as well get used to it. And let's actually just write it up here on the side. Very generally, if you have something added together like a plus b squared, that's just a plus b times a plus b, which is going to be a squared plus a times b plus a times b is 2 times a times b plus b squared. That pattern happens a lot, so we might as well just kind of memorize it. So 5 plus h squared is going to end up being 5 squared plus 2 times 5 times h plus h squared minus 3 times 5 squared is 25 all over h. Doing a little more simplifying, distributing the 3 here. Now, I'll point out, at this stage, you might notice that the 3 times 25 here and the minus 3 times 25 here are going to cancel out. And if that multiplication is really hard to do, you don't need to do it. Like there's a homework problem where I think you have to do like 7 times 16 and a minus 7 times 16. That's my version of it. And that's kind of a big number. I don't need to do that if I don't need to do that. So, but here 3 times 25 is not that bad, it's 75. So you're going to get 75 minus 3 times 10 times h is going to be 30h. 3 times h squared is 3h squared. 3 times 25 is minus 75 over h. The 75s cancel. We're left with the limit as h goes to 0 of negative 30h plus 3h squared over h. A couple different ways to go here. Some people like to jump straight to kind of I'm going to skip a step, but I'll fill it back in a second here. Some people just like to divide each thing by h. 30h or negative 30h divided by h is negative 30, and 3h squared divided by h is just 3h. Some people prefer to take the path of factoring out an h from the top. So we would have h times negative 30 plus 3h divided by h. And the h divided by h cancels out. This happens almost every time we do this type of limit, where you simplify the top, and after you've done whatever you need to do, you will get to a place where everything in the numerator has an h in it. Factor out an h and then cancel the h at the bottom. Because I should say, your ultimate goal when you're calculating a limit like this, before you actually take the limit, your goal is to cancel out that h that's in the bottom. Not some other h that ends up in the bottom later, but that's specifically that first one that is in the denominator. We need that to cancel out so we're not dividing by 0. So then we can plug in h going to 0 and we get negative 30 plus 3 times 0, which is just negative 30. Okay, so here is some context. This limit that we just calculated was actually the limit definition of the derivative of a function at a point. So what we did, in fact, let me just point out the derivative of f of x at x equal to a is given by f prime of a is often how we write it. It's not the only way of writing it, but it's a typical way of writing it. And it's equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. So with that context, we can see here that what we just calculated was, well, if our function was 3 times x squared, and our a was 5, we just calculated f prime of 5. And it was equal to the limit as h approaches 0 of f of 5 plus h minus f of 5 all over h. And then we plugged in 5 plus h to the function, and we got 3 times 5 plus h squared, and we plugged in 5 to the function and got 3 times 5 squared. So this is how we use the limit definition of the derivative to calculate the derivative of a function at a point. A couple other things to observe here. This is how you find the slope of the tangent line at a point. So it's very important to know one interpretation of the derivative of a function at a point. So the derivative of f of x at the point a comma f of a is, or I should really say, can be thought of as the slope of the tangent line at that point. The reason I say can be thought of as and not just is because there are other ways of thinking about what the derivative means. Very, very generally, and I want you to take this to heart, the derivative of a function is the rate of change of that function. It is how the output is changing as the input is increasing. So when we talk about the derivative being the slope of the tangent line, we're saying, well, in fact, let me just draw a little picture here. We're saying here is like, you've got some function that looks like that, and you want to find, say, what's happening here. Well, right here at this point, a comma f of a, this function is increasing, right? It's getting bigger from left to right. And the rate at which it is increasing is approximately the slope of this tangent line. We're saying, oh, right there, if you go over x, you're going to go up about that much y. And that's the whole idea, is that the rate of change is how the output y is changing as the input x is increasing. I do specifically say increasing there because we're usually thinking from left to right. So x is increasing, you're asking, what's y doing as x is increasing? That's really the very, very general idea of what a derivative is. But then it allows us to answer the kind of questions like for that previous function, for f of x equal to 3x squared, what is the equation of the line tangent to f of x at x equal to 5? Okay, to find an equation of a line in general, tangent line or any line, you need two pieces of information. We need a slope, which we literally just found. The slope was, I literally just forgot what it was. The slope was -30. And you need any old point. Well, the only point we have is the point when x is 5, and if x is 5, f of 5 is going to be 75. So our point is going to be 5 comma f of 5, which is 5 comma 75. You can do this in one of two ways. My preferred way is always to use the point slope form and then to modify it. So I would do this as, okay, y minus the y coordinate equals the slope times x minus the x coordinate. That's the way I like to do this kind of problem. Some people, web work included, are cool with you leaving it like this. Some people are not. Some people want you to write it in the y equals mx plus b form or the slope intercept form. To do that, you would first distribute the -30 here. We're going to get y minus 75 equal to -30x minus 30 times minus 5 is plus 150. And if we add 75 to both sides, we're going to get y equal to -30x. 150 plus 75 is 225. So that's your slope intercept form, which you would have to do, say if web work gave you, said write the answer and they already wrote y equals for you, then you would have to write just -30x is 225. On the other hand, if Weber says just write the equation of the line, you could write it like this, or you could write it like this, or some other equivalent way. So this is the point slope form. Both are valid. Question so far? Okay, we're gonna do a couple more like this, but I'm gonna make a couple extra comments. So yeah. Let's look at the next one. Think about that for a second. So, same sort of idea. We want to use the limit definition of the derivative to find the derivative of y equal to the square root of 2x plus 5 at x equal to 2. And we're going to do this in two ways. So it's going to be a little bit of writing, but I want you to see both ways because I think it's worthwhile. So first way. Okay, limit definition is something you definitely want to memorize. It's always going to be f prime of whatever equals the limit as h approaches 0 of f of whatever plus h minus f of whatever all over h. That's the very general way of doing it. And here we're trying to find the derivative when x equals 2. So we're going to say f prime of 2 is equal to the limit as h goes to 0 of f of 2 plus h minus f of 2 all over h. I will point out there are alternative versions of the limit definition of the derivative, but the one I'm showing you is probably the one you're seeing. It's also the one that's easiest to compute. Some people do this thing where they do like f of x minus f of a over x minus a. If your teacher talks about that, let me know, but I don't think they will. It's not atypical, it's just this is the better way. All right, so then we're going to plug in these things to our function. So f of 2 plus h, this is our function here. This y is our f of x. So we're going to get the limit as h goes to 0. Let's see, f of 2 plus h is going to be the square root of 2 times, instead of x, I'm going to write 2 plus h plus 5. Minus f of 2 is the square root of 2 times 2 plus 5. All over h. When you're finding the derivative at a particular point like this, it is definitely in your interest to simplify this second part here. This f of 2 is just the square root of 9, which is 3. I don't want to write the square root of 4 plus 5. I can write 3. So let's simplify this a little bit before we do anything else. This is going to be the limit as h goes to 0 of, so inside here, 2 times 2 is 4, and 4 plus 5 is 9. So the square root of 9 plus 2 times h is 2h. I can't simplify that anymore. I can't say it's like 3 plus something because their addition doesn't work well with square roots. Minus the square root of 9, which is 3, all over h. Okay, here's the thing we've been waiting for. This is why we spent time practicing 0 over 0 types of limits. This is the 0 over 0 limit. If you plug in 0 for h, what do you get on top? 0. What do you get on the bottom? Also 0. And that's why we spent time doing these, because all of these limit definition of the derivative problems are going to be 0 over 0 limits. And so we're going to use all the techniques, all of the algebra techniques where we're going to, hey, multiply by the conjugate. So we're going to multiply by the square root of 9 plus 2h plus 3 over the square root of 9 plus 2h plus 3. And then we're going to simplify. Still have a limit, so the limit as h goes to 0. As we've seen with conjugates, when you multiply them together, you just get the first thing squared minus the second thing squared. So here we're going to get just the square root of 9 plus 2h squared, which is 9 plus 2h, minus 3 squared. All over, we don't multiply out the things that aren't conjugates. H times the square root of 9 plus 2h plus 3. And the reason we don't multiply the conjugates is because the not conjugates is because we are looking to cancel out that h, right? Just like before, that h is is the person we want to make good, is the thing that is not good. We want it to go away. It's causing us problems. So it's going to work because on top I've got 9 minus 9. Those cancel out. And then I've got 2h over h. I would probably skip this step if I was a student doing this problem, but I'm going to show it. I'm going to go 2h over h times all this stuff. But then the h's cancel because h divided by h is just 1. And then we have a limit as h goes to 0 of 2 over the square root of 9 plus 2h plus 3. Finally, take the limit, plug in 0 for h. You get the square root of 9 plus 2 times 0 plus 3, which is 2 over 3 plus 3, which is 1/3. Okay, and here's a follow-up question. What if I said, now I want you to tell me what the derivative of this function is when x equals 5? We have to do all that work again, except we have to plug in 5 instead of 2, which seems like a lot. So here's what I really want you to see. Instead of doing this multiple times for different values of x, we're just going to do it for an arbitrary value of x. I think in problem 7 in this homework assignment, they use a instead of x. It doesn't really matter what letter you use. So we can use a or we can use x. But the idea here is instead of finding the limit definition, am I going to have enough room? Maybe. Yeah, I'll have enough room. So now let's do it again, but instead we're going to find the derivative in the same sort of way, but now we're going to do it at x equal to a. So we're going to say, great, f prime of a is equal to the limit as h approaches 0 of f of a plus h minus f of a all over h. And I didn't write the a's because I was going to fill them in red. It's very much the same process. It's usually a little bit more computationally complex though. Let's see what we get. Get the limit as h goes to 0. Let's see, f of a plus h is going to be the square root of 2 times a plus h plus 5. F of a is going to be the square root of 2 times a plus 5 all over h. Now, unlike the previous one, this square root over here isn't going to simplify. Right? We can't do anything with that other than leave it as it is. So at this point, here's what we're going to multiply by the conjugate. The conjugate is going to be, I could write this as 2a plus 2h plus 5 if I wanted to. I guess I might. I think I made my square root too long there. Sorry, 2a plus 2h plus 5 plus the square root, sorry, of 2a plus 5. And I'm squeezing that in there. I apologize. That looks kind of gross. And then over the same thing, square root of 2a plus 2h plus 5 plus the square root of 2a plus 5. And just like before, we multiply out the things that are conjugates. So on top, we're going to get 2a plus 2h plus 5 minus 2a plus 5. Now, I want you to, well, in fact, I'm going to write, so I've made a small error, which I'm going to correct on purpose. Let me write at the bottom first. On the bottom, I have h times all that conjugate stuff, the square root of 2a plus 2h plus 5 plus the square root of 2a plus 5. Okay. Here's what I want you to see. Right now, if I start canceling stuff on the top, what's the only thing in the numerator that actually cancels out the way I've written it? Yeah, 2a is the only thing. But we know that we're supposed to be able to cancel the h in the bottom. And to be able to cancel the h in the bottom, everything that doesn't have an h in the top should have canceled out. The reason why it isn't is because I forgot the parentheses here. Right? When you have this times this minus this times this, it's minus all of that times that. So that has to have parentheses if there's more than one term. And then we can see, oh yeah, 2a minus 2a cancels and 5 minus 5 cancels. So then we're left with the limit as h goes to 0 of 2h over h times all that stuff, square root of 2a plus 2h plus 5 plus the square root of 2a plus 5 and then the h's cancel. And then we can let the rest of the h's go to 0. So then we get 2 over the square root of 2a plus 0 plus 5, which is just 2a plus 5, plus the square root of 2a plus 5. Okay, here's a place where people often make a small error. The square root of 2a plus 5 plus the square root of 2a plus 5 is 2 times the square root of 2a plus 5. Not just, right, you're not multiplying them and canceling the square root out, you're adding them, so you're getting double. So you get 2 over 2 times the square root of 2a plus 5, and then I can't cancel those 2's. So I end up getting 1 over the square root of 2a plus 5. That's f prime of a. Now I'll point out, now I can find f prime of 2 really easily. If I plugged in 2 for a, I get 1 over the square root of 2 times 2 plus 5, which is 1 over the square root of 9, which is 1/3, just like I got here. But I can also plug in 5 really easily. I might say 10, not 5. Oh well. I can plug in 10 really easily and get f prime of 10 is 1 over the square root of 2 times 10 plus 5, which is 1 over the square root of 25, which is 1 over 5. So here's kind of the big picture for a second. We can keep finding derivatives at points this way, but it is more efficient to start finding the derivative kind of as a function of whatever a you want to plug in. And use it, and we're going to switch from using a to using x because x is our usual variable. But that's the idea, is instead of finding the derivative at a particular point, we're going to find the derivative in general and then plug in whatever points we happen to need. So let's ask a follow-up question. For this example, what is the equation of the line tangent to y equal to the square root of 2x plus 5 at x equal to 2? Well, we have all the information we need. Our slope is f prime of 2, which is 1/3. And our point is 2 comma f of 2, which is 2 comma square root of 2 times 2 plus 5 is 3. And then you just stick that stuff together in your point slope form. Y minus the y coordinate equals your slope times x minus the x coordinate. And you should probably get in the habit of solving for y, because usually people want you to solve for y. So y minus 3 equals 1/3 x minus 2/3. If I add 3 to both sides, y equals 1/3 x minus 2/3 plus 3, which is 9/3. So I end up getting y equal to 1/3 x, and negative 2/3 plus 9/3 is 7/3. That is my equation. All right, I want you all to take a minute, do the same thing, but now find the equation of the line tangent to y equal to the square root of 2x plus 5 at x equal to 10. I'll remind you, we just found that the derivative f prime of a is equal to 1 over the square root of 2x plus 5. So you can definitely find the slope as f prime of 10, whatever that might be equal to. Give you a minute and a half. By the way, for those of you on Zoom, here's a link to the attendance form. Oh, for those of you in class, I didn't put it up. I'll put it up while you work on that. You can scan it when you have a free moment. Don't stop working to scan. Yeah, we'll do that one too. That one's gross, but we should do it. Okay, it's been a minute and a half. So let's find all the things we need. So my slope is f prime of 10, can be 1 over the square root of 2 times 10 plus 5. That's 25. So the square root of 25 is 5. My slope is 1/5. My point is, it's always just x comma y. So in this case, my x is 10, my y is f of 10. So it's 10 comma f of 10. And f of 10, well, if I plug in 10 here, the square root of 25 is 5. So it's 10 comma 5. And then, I'll do this one the other alternate way. So usually I would always use the point slope form. I would prefer to do y minus 5 equals 1/5 times x minus 10. But you might not like doing it that way. The other way you can do this is to say, well, I know that y equals mx plus b. So I'm going to start with y equals 1/5 x plus b. And then just plug in the point that you have on the line. So if I plug this in, I'm going to get 5 equal to 1/5 times 10 plus b. And then I can solve for b. So 5, see, 1/5 times 10 is 2. Subtracting 2, I get 3 equal to b. The only part I don't love about doing it this way is then at the end, you feel like you're done because you found b, but then you have to go back and rewrite the equation on the line with your b value in it. So I should go back and say, okay, that means y equals 1/5 x plus 3. Either way is totally fine. I prefer doing it this way. If you like that better, though, do that. Questions so far from anyone on Zoom or anyone in the room? Okay, we'll do one. Oh, question, Lyle, sorry. Yes. So to get the y coordinate, I'm taking the x coordinate and plugging it into the function that's given to me. All right. Let's look at one more in this kind of vein, and then we will move on to a couple other things I think are worthwhile as well. I mean, everything's worthwhile, but something's more than that. So let's look at the file. Oh yeah, so this one I made up is very similar to problem 4 on this homework assignment. On section 3 problem, which I did see that the dates have been moved back to like after your midterm, right? Like this homework's due like the 13th or something, or what, I don't know exactly, right? On top question, how do we get 7/3? Oh, sure. I didn't show all my work, but what I did was right here, I noted that 3 really is 3 over 1, and then I multiplied it by 3 over 3 to get a fraction. So I have -2/3 plus 9/3, and -2/3 plus 9/3. We add the tops and you get -2 plus 9, which is 7. That's how you're getting there. Yeah, no problem. All right. Also, for those of you on Zoom, I imagine everyone knows this, but just in case you don't, if you want to ask me a question privately, you can send me a message just to me and not the whole group chat. You're totally always welcome to do that. So here's one that's like problem 4, which is a little bit dicey. So for f of x equal to 3x plus 4 over x plus 6. So I'm going to phrase the question how you'll probably see it on the exam, which is find the equation of the line tangent to this function at x equal to, what did I pick here? 1. So that means we have to do 2 things. We have to find the slope of the tangent line, and we have to find the point of tangency. The point of tangency is not too hard. The point is just whatever your x value is, comma, whatever your y value is. If I plug in 1 here, I get 1 comma, let's see, 3 plus 4 over 1 plus 6, which is 7 over 7, which is 1. My point is 1 comma 1. The point's usually pretty easy to find. The slope, on the other hand, that's where we have to find the derivative usually. So the derivative here at 1. And I am going to show you both ways of doing it, because again, I want you to see it. Here's again, let me give you kind of a preview of what we're working to. Eventually, and some of you may have had calculus before, you might already know this, but even if you don't, okay. Eventually, we're going to move past this limit definition of the derivative. And we're not going to spend 5 minutes doing all this algebra every time to calculate the derivative. And we're going to learn some rules and techniques about how we differentiate different types of things. For now, all we have is the limit definition. But we have two varieties of it. You have the limit definition at a point. So I'm going to do it that way first. So f prime of 1 is going to be, you should not, in fact, I want everybody to write down the limit definition. So I want you to write down the limit as h approaches 0. Don't actually write the function, just write f of whatever. So you should have f of something minus f of something over something. I'll give you 30 seconds. You should do it at home too, or wherever you are. Got like 5 more seconds. Okay, that's going to be f of 1 plus h minus f of 1 all over h. So whenever someone says limit definition of the derivative, this is immediately what we should be thinking of. F of whatever plus h minus f of whatever all over h. The only thing that differs is if you've got the number here or the letter a here or the letter x here. But it's always the same format every single time. And now we're going to actually use the function. So, okay, now things are going to get gross. You might not want to actually write this down. It's kind of messy, but you're certainly welcome to always. So we're going to get the limit as h goes to 0 of, let's see, f of 1 plus h. I'm plugging in 1 plus h for every x. So I'm getting 3 times 1 plus h plus 4 over 1 plus h plus 6 minus, we know the f of 1 is 1. So I don't want to show all that work. Maybe I'll show it one step. I'll plug it in right here. You get 3 times 1 plus 4 over 1 plus 6 all over h. Gross. Okay, we know the goal is to make that guy cancel out. Cancel that h. It doesn't cancel yet. We have to do it. So let's simplify a little bit. I'm going to write this as the limit as h goes to 0. On top here, I have 3 times 1 and 3 times h. So I have 3 plus 4, which is 7, plus 3 times h is 3h. In the bottom, I just have 1 plus h plus 6, which is 7 plus h. And on the bottom, I have, sorry, not the bottom, minus 1. Do I want to write it like that? Yeah, no, sure. All divided by h. I need to subtract some, I have a fraction minus a thing. When you want to add or subtract fractions, we have to get a common denominator. So this 1 is going to become 7 plus h over 7 plus h. You need the denominators to match. Or you can think of multiplying 1 over 1 by 7 plus h over 7 plus h. Same idea. This is going to equal the limit as h goes to 0 of 7 plus 3h over 7 plus h minus 7 plus h over 7 plus h. And when I have fractions and fractions like this, to make my life a little bit easier, instead of keep writing these fractions all divided by h, it is equally good to say we have all of this times the reciprocal of h. Right? And if you need to, you can say, oh, really, you have h over 1 here. And when you divide by a fraction, you flip and multiply. So that's why we're multiplying by 1 over h, not h. Okay, but now we actually can put these two fractions together as one fraction because they have a common denominator. So this minus this is just the top minus the top, and the bottom stays the same. So we're going to have, and be careful here, we're going to get on the bottom 7 plus h times 1 over h. On the top, we have 7 plus 3h minus, is it minus 7 minus h or minus 7 plus h? I guess that's not a fair question because I'm not telling you if there's a parentheses. If I didn't write any parentheses, would I need minus 7 minus h or minus 7 plus h? Good question. Minus 7 minus h. Because this minus sign does distribute to all the terms in the numerator of that fraction. really we have minus all of this, but really it's just minus. So yeah, the 7s cancel. 3h minus h is 2h. Now we have the limit as h goes. Yeah, good. Thank you. Thank you on the message. Limit as h goes to 0 of 3h minus h is 2h. And on the bottom, when you have fractions multiplied together, you can do the top times the top and the bottom times the bottom. So I can totally write this as the denominator being just 7 plus h in parentheses times h. And the h that started out in the bottom, let me circle it a few times here. This h, this h, this h, this h, this h, this h. That h is going to cancel out because 2h divided by h, or just h divided by h, is 1. Those definitely cancel. And then we're left with, I would probably skip this step. The limit as h goes to 0 of 2 over 7 plus h. Let's just plug in the 0 for h and get 2 over 7 plus 0. Okay. And now I'd really also like to know, do I want to know? What's the derivative when x equals 2? I want to know that again. So, right. So again, I'm just trying to emphasize the fact here that if you had to find the slope of the tangent line or the derivative of this function at more than one point, doing this repeatedly is dumb, right? It's way too much work. So instead, what we would rather do, and let's see, how much space is it going to take up? Yeah, let's use a whole new page. Let's use a whole new. So before we finish answering this question, which we will come back to do down here, I want to take this derivative again, but in a more terrible, but also better way. So instead, we can say f prime of x. The derivative as a function of x is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Now, if you think that one was bad before, this one is going to be worse. That's okay. Let's remind ourselves our function was 3x plus 4 over x plus 6. So for f of x plus h, all we're doing is replacing each x with x plus h. So we're going to get a limit as h goes to 0. F of sometimes if you like what is helpful to do actually is just off to the side, write out what f of x plus h is going to be. So f of x is 3x plus 4 over x plus 6. F of something else is 3 times something else plus 4 over something else plus 6. And that's going to be x plus h, x plus h, x plus h. It might be helpful to do that because something I will say over the years, I definitely noticed people often make a mistake when they write what f of x plus h is. You're just subbing in x plus h for every x. So you're getting 3 times x plus h plus 4 over x plus h plus 6 minus, and then f of x is just 3x plus 4 over x plus 6 all over h. Clear. Everyone can see all the things. F of x plus h minus f of x all over h. And now I'm going to do one bit of simplifying here, but I'm going to leave myself some room. You might want to watch for just a second while I do this next step, and then I'll pause for a moment. So I'm going to rewrite. So the top is going to be 3x plus 3h plus 4 over the bottom, which is x plus h plus 6. I don't need those parentheses. Leave yourself some room here. Minus over here, it's just 3x plus 4 over x plus 6. And leave yourself some room here. And then it's going to be all of that times, instead of dividing by h, we're going to multiply by 1 over h just to make it easier to write out. And the thing I want to multiply by is the thing I need to multiply by to get the common denominator. So here I have to multiply by x plus 6 over x plus 6. And here I have to multiply x plus h plus 6 over x plus h plus 6. There is no nicer way of doing it. You can't just throw in an h there and an h on top. How I wish we could. We cannot. Okay, and then things are going to get gross. So, okay, oh, sorry. So if you want to write that down, write it down. Instead of pausing. Pause and take a sip of water. So here's what I know now. This expression has a common denominator. That common denominator is x plus h plus 6 times x plus 6. So this fraction inside the parentheses is going to be x plus h plus 6 on the bottom times x plus 6. On the top, I actually have to multiply it out. So I have to FOIL this. It's not even really foiling. It's just kind of doing the whole thing. So I'm going to do 3x times x, 3x times 6, 3h times x, 3h times 6, 4 times x, 4 times 6. I don't think I left myself enough room. Minus, so now it's going to be minus all of this next part. So again, 3x times x, 3x squared, 3x times h, 3xh, 3x times 6, 18x, 4 times x, 4x, 4 times h, 4h, 4 times 6, 24. All time, in fact, instead of saying all times 1 over h, let's just put the h in the denominator over here as well. If there were a coefficient out in front here, which there often will be, you need to multiply it out before you start canceling stuff. But since there isn't, I can kind of be careful and cancel things. 3x squared and negative 3x squared cancel. 18x and negative 18x cancel. 3hx and negative 3xh, those are the same thing except opposites, those cancel. So normally I would say all the non-h things cancel, but sometimes some of the h things cancel as well. We definitely need all the things that don't have an h in them to cancel out. Sometimes some of the things that do have an h also cancel. Totally fine. 18h doesn't cancel. 4x and a minus 4x cancels. And 24 and a minus 24 cancel. Okay, so here's what we're left with after all that. Left with the limit as h goes to 0 of 18h minus 4h all over x plus h plus 6 times x plus 6 times h. The top simplifies as 14h all over the same denominator, x plus h plus 6 times x plus 6 times h. Finally, the h's cancel. Not all the h's, right? Just the ones that are kind of factored out from everything on top and the bottom. And then we're left with the limit. H goes to 0 of 14 over x plus h plus 6 times x plus 6. And plugging in 0 for h, we get 14 over x plus 6 times x plus 6, which is 14 over x plus 6 squared, which is our derivative f prime of x. And then just double check that the work we did before was right. If you plug in 1, was it 1? Yeah. F prime of 1 is going to be 14 over 1 plus 6 squared, which is 14 over 7 squared, which is 49. And then you can reduce by a 7. And 14 divided by 7 is 2. And 49 divided by 7 is 7. And that is the same answer that we got before. So good, it worked. Now, why was it worth going through all this pain? Because now we can also say, well, also f prime of 2, I can just plug in 2 now and say it's going to be 14 over 2 plus 6 squared, which is 14 over 64, which probably reduces to something that I don't care. And I can plug in any other value of x except for negative 2, or sorry, except for negative 6, and get the derivative at that point. So this is the point, is that if you find the derivative as a function of x, you can then use it to find the derivative anywhere you want. And that is definitely the direction that we are moving in. Okay, so now back to the original question. What's the equation of the tangent line when x equals 1? Well, I've got the slope, I've got the point. Finding the tangent line equation is not too terrible. It's y minus the y coordinate equals the slope times x minus the x coordinate. And then if you want to solve for y, first distribute this 2/7 here. So y minus 1 equals 2/7 x. 2/7 minus 1 is minus 2/7. Add 1 to both sides, so y equals 2/7 x minus 2/7 plus 1. Here's the work you would actually show to do that. Y equals 2/7 x minus 2/7, and 1 becomes the fraction 7/7, and then negative 2/7 plus 7/7 is positive 5/7. Cool. All right. Kind of a pain, but not too terrible in the grand scheme of things. Let's look at, so I just kind of made up some problems. They're similar-ish kind of for your homework questions, just kind of illustrate a few things. Let's look at this next one here. So let's say, so here's an example. If the tangent line to your function y equal to f of x at the point -4, 9 passes through the point (0, -11), find both f of -4 and f prime of -4. Based on what I've written down here, everybody should be able to, within the next 5 seconds, write down what f of -4 is equal to. Those of you on Zoom, I would love to see in the chat what you think f of -4 is. Like, no, yeah, nobody, anybody? You guys are like, it's on mute. Okay, so here's the thing. This function has the point -4, 9. That means f of -4 must be equal to 9, because the x value is -4 and the corresponding y value is equal to +9. So f of -4 is not too terrible. It's just +9. That's it. And that is coming directly from the fact that this function, the tangent line at this point, well, what we're saying there is that means the tangent line goes to that point. Let me show you graphically what's happening here. I don't know what this function actually looks like. I'm going to make something up. Let's say my function looks vaguely like this. I'm really just making it up. And here's the point of tangency, -4, 9. Oh, yeah, if I plug in -4, I get 9. And here's my tangent line. I didn't draw this steep enough. Sorry. I'm gonna move that point up here. Make it a little steeper looking. Sorry, it's right there. That one, not that one. Okay. And here's my tangent line. Going through the point -4, 9 on the graph, and 0, -11 over there. If I want to find f prime of -4, what does f prime of -4 mean? Like, what are words I could use to say it? What does f prime mean? What are the words? That's excellent. I love that answer, but I'm looking for an answer, a slightly less general answer that starts with the letter D. The derivative, f prime of -4 is the derivative at -4. But the derivative can also be thought of as the slope of the what? Right. Can you find the slope of that line? Let me rephrase that question. Can you find the slope of that line that goes to the point -4, 9 and 0, -11? Oh yeah, we can find the slope using the slope formula. So here we're going to find the slope of this derivative, or we're going to find the slope of this tangent line equal to the derivative as just the slope formula, y2 minus y1 over x2 minus x1, which is going to be, doesn't matter which way you do it, I'm going to do -11 minus 9 over 0 minus -4. Or if you prefer, you could have done it as 9 minus -11 over -4 minus 0. Either way is correct. Either way, here we're going to get -20 over 4, which equals -5. Here we're going to get positive 20 over negative 4, which equals negative 5. So if you know that the tangent line is tangent at a particular point and goes through another point, then you can totally find the slope of that tangent line, which is the derivative at that point. It's not the derivative everywhere. I have no idea what the derivative function is at, say, negative 3, but I know the derivative of negative 4 has to be the slope of the line connecting those 2 points, which is nice. Cool. And that's similar to problem 6, I think, number 5. Oh yeah, that one's weird too. Cool. Yeah. Did I miss something here in my own notes? Let me check my own notes here real quick. Oh yeah, got that one too. Oh yeah. Sorry, I got brain things all over the place here. Sure. So let me ask you all to try a similar problem. We got time. Yeah, we got time. Convincing myself here. No, actually, I changed my mind. Let's do this. So let's do this next problem. Let's find the equation of the line tangent to the graph of y equal to f of x at x equals 17 if f of 17 is equal to 8 and f prime of 17 is equal to 10. And we're actually going to do another version of this as well. So we have all the information we need. Find the equation of a line, right? Equation of a line doesn't matter if it's a tangent line or any other line. Equation of a line, you should automatically think, I need 2 things. What are the things we need to find the equation of a line? Slope is definitely one of them. What other thing would be good to have? Any old point will do. And I'm glad you said a point, right? You can certainly say the y-intercept would be lovely to have, but really any point is great. And any point. Okay, I want everyone for me to take 30 seconds and write down what the slope is at this point and what the point is at this point. Sorry, that seems kind of silly, but you get the idea. What's the slope? What's the point? And the point should be an XY coordinate. And the slope should be a number. Yep, that's exactly right. Yes, that is a correct answer there. Oh, yeah. And if you have found both things, you can go ahead and try and write the equation. I wasn't timing. Right, if we're looking for the line tangent to the graph of y equals f of x when x is equal to 17, well, the slope is going to be the derivative when x is equal to 17. That's just going to be f prime of 17, which we were told was 10. And the point, well, we already know half of the point. The point is the x coordinate is, or the half we know is that x is 17. And the y coordinate is always just whatever the function value is when you plug in the x value. So it's f of 17, which is also given to us. So there's our point, there's our slope. So the way we find, so the thing is, we don't actually have the equation here, right? They didn't ever tell us what the function was. They just said, we know this information, but that's enough information to be like, oh yeah, we know the point. So then the usual thing, y minus the y coordinate equals the slope times x minus the x coordinate. And then we can simplify this as y minus 8 equals 10x minus 170. We add 8 to both sides. y equals 10x. Minus 170 plus 8 is minus 162. What if we change this problem just slightly? What if instead of saying f prime of 17 was equal to 10, I changed it and said, now we have the same question, but f of 17 is still 8, and f prime of 17 is 0. 0 is very unexciting as a slope. Because if your slope is 0, what does it mean about your tangent line? What kind of orientation does it have? Yeah, exactly. If your slope is 0, your tangent line is horizontal, like the horizon. So what happens here? Luckily, you don't actually have to know that to still do this. We can still apply the same logic. My point is still going to be 17, 8. But now my slope is 0. So when I write my equation, I'm going to get y minus 8 equals 0 times x minus 17. I don't need to distribute this at all because 0 times anything is just 0. So I end up getting y minus 8 equal to 0, or more likely y equal to 8, which should make sense, right? If we know the line is horizontal, we know it should be y equal to a constant. It feels like a disappointing result, but it is what the result is. Got here, let's see. And one other homework like, oh no, I had that too. Yeah. I got all kinds of plans. These are good homework questions, but like the homework questions on for this 3.1 section, I think are good questions. Let's look at this next thing. So let's say they gave us that, we're given that f prime of a is equal to the limit h goes to 0, 17 times the natural log of 8 plus h minus 17 times the natural log of 8 all over h. So 2 questions. What is a? And what is the function? And as a reminder, f prime of a is equal to the limit as h goes to 0 of f of a plus h minus f of a all over h. So I want you all to take a minute and try to first figure out what a is, and then figure out what f of x has to be. And if it were me, I would be looking at this top part and seeing, well, where's the a plus h and where's the a? How can I differentiate between them and see what a has to be? All right, people look like they might be done. So what's a good candidate for a here? Yeah, it's got to be 8. Because here I have a plus h, and here I just have the a. And then the other question is, what's the function that we're plugging the 8? So I would personally, if it were me, I would focus right here. So focus right here, I'm like, well, that's f of a. I plugged in 8 to this function. The function I plugged it into was 17 natural log of whatever, of x. So my function here has to be 17 natural log of x. And you can see, oh yeah, here I'm getting 17 natural log of a plus h. Here I'm getting 17 natural log of a. So that's definitely my function. Later on, we are probably gonna have homework questions where they give you an expression like this and ask you to calculate it, not by actually taking the limit, but by recognizing it's the derivative of a function and then using a different method of differentiating that function. We learn all our derivative rules. Okay, let's look at this. Yeah, let's look at this. Let's look at this motion question. So, yeah. If a rock is thrown upward on Earth, not Mars, like your homework question. Is it Mars? Yeah, on planet Mars. Earth here, from an 80-foot high platform. With an initial velocity, I can spell, of 64 feet per second. Its height after t seconds is given by the equation h of t is equal to negative 16t squared plus 64t plus 80. Sorry if my t look like pluses too much there. Let's ask some questions. So question 1, what is the velocity of the rock after 1 second? It's kind of like a hard question to answer without a little more context. So velocity is the derivative of position. So you think about it, position, if we're talking about in feet here, like, so let's actually, before we get to this question, let's answer a different question. Let's say we know that the height at time 0 is 0 plus 0 plus 80, which is 80 feet. And the height after 1 second is negative 16 plus 64 plus 80, which is going to be 128, I think. Right? Yeah. So in that 1 second, the rock traveled 48 feet. Make sure I'm not making a mistake here. No, that's right, yeah. And so you could say it's average velocity in that time frame. So the average velocity is going to be the height at 1 second minus the height at 0 seconds over 1 minus 0, which is 128 minus 80 over 1, which is 48 feet per second. I really want to point out that the rate of change here, feet per second, is the derivative of position. Right? If I'm walking this way, my position is increasing. My rate of change is how much position is changing per unit of time. That's another interpretation of what a derivative is. It's the rate of change of something like this. So the question, how do I find the velocity after 1 second, is really code for find h prime of 1. It wants to find the derivative of this function at time equal to 1 second. Okay, well, we know how to find derivatives. Now, the question here is, do we want to do this generally, or do we want to do it just at a equal to 1? And looking at the homework question, well, the next question is find the velocity of the rock when time equals a. So we might as well just do it generally, since we're going to have to do it generally. So let's actually skip this question, come back to it. And question 2 is velocity of the rock when time equals a. In other words, they're asking to find h prime of a. Oh, h is a terrible choice here because we use h in our limit. So I'm going to call this, like your textbook smartly did, I'm going to call this capital, or not your textbook, your homework assignment. I'm going to call this capital H. Make it less terrible. Yeah, good call. I was like, why are they using capital H? That seems weird, but now I understand. So to find capital H prime of A, it's the usual thing. It's the limit as H, little h goes to 0 of capital H of A plus H minus capital H of A all over. Same thing every time for this limit definition of the derivative. You're just doing the, really, it can't be any more the same every time. So now we're going to do it. So here's our function. And we're going to plug in A plus H for every t. We're going to get the limit as little h goes to 0 of, let's see, negative 16 times A plus H squared plus 64 times A plus H plus 80 minus all of H of A. So H of A is going to be negative 16 times A squared plus 64 times A plus 80. All divided by H. And just like in the previous problems, we should be able to simplify this in such a way that all the things that don't have an H cancel out. We have to do a little bit of work though. So let's see here. And I need more room because I'm going to run out of room. So this is going to equal limit as H goes to 0 of, so we need to first multiply this A plus H squared. So that's going to be the negative 16 times A squared plus 2AH plus H squared. Distribute the 64. So you get a 64A plus 64H plus 80. And then distribute this minus sign. The minus and minus is plus 16A squared minus 64A minus 80 all over H. And at this point, I can cancel a few things. The 64A and the negative 64A cancel, and the positive 80 and the negative 80 cancel. I can't cancel out this 16A squared yet because I haven't distributed this negative 16 here yet. So I have to do that in the next step. So then we're going to get the limit as H goes to 0 of negative 16A squared minus 32AH minus 16H squared plus 64H. That, and then also that plus 16A squared. Finally, cancel the 16A squared with the negative 16A squared. And now all the remaining terms that I haven't been able to cancel out all have an H in them. So we're in a good spot. That's what we're trying to get to. Because now we can factor out an H from the numerator. The limit as H goes to 0 of H times negative 32A minus 16H plus 64 all over H. The H we factored out gets to cancel with the H in the denominator. And then we're left with the limit as H goes to 0 of negative 32A minus 16H plus 64. And plugging in 0 for H, we're going to get negative 32A minus 0 plus 64. So we can see that H prime of A, which is the velocity of the rock at time A, which you might even write as V of A, is going to equal negative 32A plus 64. And then we can go back and answer the first question. That means that H prime of 1, well, H prime of 1 is going to equal negative 32 times 1 plus 64, which is equal to negative 32 plus 64, which is 32 feet per second. So after 1 second, the rock has slowed down significantly, right? It started off being thrown at a speed of 64 feet per second, and after 1 second, it is going 32 feet per second. And just because I think it's interesting, after 2 seconds, you get negative 32 times 2 plus 64. That's going to be 0. And after 3 seconds, you get negative 32 times 3 plus 64. That's negative 96 plus 64, which is negative 32 feet per second. What does it mean that the velocity is negative? Right, it's going down, going the opposite direction. So typically when you're throwing a rock upwards, we usually imagine the upward directions having a positive velocity and the downward directions having a negative velocity. It's also worth noting on Earth that acceleration due to gravity is negative 32 feet per second per second. So every second that the rock travels, it loses a speed of 32 feet per second, which we can totally see. The rock started off going 64 feet per second. A second later, it was going 32 feet per second. A second later, it was going 0 feet per second. A second later, it was going negative 30 feet per second. So every second, it loses 32 feet per second of speed. Okay. How much time? Okay, enough. There was something else I wanted to mention here, and I've lost it. It's okay. Oh, I should probably put units on here. This is feet per second. What else do I want to ask? Okay, yeah. The other two things we often like to ask about. So I will point out, even though it's not one of the questions, I'm still going to say it anyway. When does the rock reach a maximum height? Well, reach a maximum height when you stop going up and start going down, meaning your velocity goes from positive to negative. So this rock would reach a maximum height when or at time equals 2 seconds. And then if you wanted to find the maximum height would be h of 2. And then you can go back and plug into your height function, which is negative 16 times t squared plus 64t plus 80, sorry, 64 times 2. And that would be something. Negative 16 times 4 is negative 64 plus 128 plus 80. That's going to be 144. By the way, this is a very common idea that we're going to explore a lot as class goes on. To find where a function has a maximum is usually found by finding where its derivative is. That's like something we do all the time. No, these questions are not going to be on your exam, I don't think, right? The exam is just up to through chapter 2, and this is definitely the chapter 3 homework stuff. Tuesday, we will do the exam review, but I felt like I should, well, especially back when I thought this homework was due earlier, it seemed like this is still a good use of our time. Right? We're definitely not wasting our time here. Just, yeah, this will not be on your exam. Let's answer the other two types of questions that are asked here. Part 3, did I number my other parts? I did, yeah. So 3, this is 2A here. Part 3, when will the rock hit the ground? Well, when the rock hits the ground, what do we know? Right, we know that height equals 0. So we're going to set negative 16t squared plus 64t plus 80 equal to 0. And if the person writing the problem has been kind, you can probably factor this relatively easily. What can I factor out from each of these terms here? A negative 16. And I would do negative, not positive. So I pull out a negative 16 and left with t squared. 64 divided by negative 16 is negative 4. And 80 divided by negative 16 is negative 5. And so this factors as t minus 5 times t plus 1. So either t equals 5 or t equals negative 1. So when does the rock hit the ground? Which of those does it have to be? Yeah. Why can't it be negative 1? You can't go backwards in time. Right. So your time answers typically should be positive. So yeah, this rock hits the ground 5 seconds after we threw it. And then finally, how fast is it going when it hits the ground? And actually, I should say, I'm going to ask a question. So not how fast, but what's the velocity? when it hits the ground? Well, we're just going to plug in 5 to the derivative here, and h prime of 5 is going to be negative 32 times 5 plus 64. 32 times 5 is always not my favorite, but I can do times 10 and then divide by 2 really easily. So negative 32 times 10 is negative 320, divided by 2 is negative 116. I factored out the negative 16. We don't actually need it. And negative 160 plus 64 is equal to negative 96. So the velocity is negative 96 feet per second. And even though they don't ask it in this question, they do ask it in the next kind of question. And the next kind of question is, after they ask you to find the velocity, they then say, what's the speed? So if the velocity is negative 96 feet per second, the speed is 96 feet per second. So speed doesn't care about direction. Speed is just how fast is it going? It doesn't matter if it's going up, down, left, right, east, west, north, south. So the speed here is positive 96 feet per second. And speed should always be positive. This really speaks to the idea of a vector versus the magnitude of a vector, but that's not something we get into vectors a little bit at the end of 17b, but that's not something we'll get into right now. Yeah, so just to kind of reiterate, the negative 16, I factored it out, and then I didn't set it equal to 0 because it's just a constant and it can't equal 0. So I'm just saying, oh yeah, this part equals 0 or this part equals 0, which leads to this or this. All right, and I could try to squeeze in another example, but let's just call it at 2. All right, I won't be around Friday or Monday, but I will be around Tuesday. We'll have class, we'll review one more time. If you want to take a practice final, I strongly encourage you to do so. And then you don't have to, but you're welcome to email me what you did, and I will try to give you feedback with relative speed.